Good morning, good afternoon, good evening, drone pilots, wherever you are, whenever you are. Today we're going to tell you how to create a virtual drone in the cloud that you can connect to from any computer on the internet for testing and development purposes. So first of all, what is a virtual drone? Well, ArduPilot code runs on the flight controller on the drone, and it's written in C, mostly C++. So instead of compiling it to run on the flight controller, you can compile it to run on a desktop computer or a server in the cloud. And that will have all the same software functionality as the software on the flight controller of the drone in the air. And you can simulate all the motor responses and the drone's orientation and the drone physics using a program called Software in the Loop Simulation, which is shown here on the ArduPilot webpage. So essentially you have this red box, which is the code, and then there's some physics simulator that simulates the drone response, and then you can connect to it over TCP/IP through the internet with a ground control station like Mission Planner or Q Ground Control, or Mav Proxy is a lightweight ground control station, or any other ground control station that you want. So that's what a virtual drone is. It's basically ArduPilot software running on a computer with some physics simulations. So how do you set it up? Well, again, all this is documented on the ArduPilot website. So you go to Setting Up CITL, Setting Up on Linux, and we have to compile the ArduPilot code to run on the computer. So we have to set up the build environment, and so that means you have to have Git installed, you have to download ArduPilot codebase, and then you have to install some Python tools to do the compilation and the simulation. So ArduPilot has created a script called install prereq on prereq.ubuntu.sh, which will install all those tools. So all this exists already on the ArduPilot code base, and it's documented in the ArduPilot documentation here. And so then, let's say you were able to follow all the directions and install it on one of your local computers, which you can do by following the directions. Then you can run a program called simvehicle.py, which will create a virtual drone inside of your local computer, and you can even tell it what kind of plane it's going to be, quadcopter, airplane, and so on. And then there's a YouTube video here showing you how you can create it with a command line, and then there's a lightweight ground control station called Mav Proxy that you can use. So that's all that ArduPilot has for you already. So what I'm going to show you today is how to install it on a cloud computer with some scripts that I wrote with the help of AI, so that you don't have to follow all the directions of ArduPilot, and you don't have to worry about having a local computer on your desk and running it manually. It'll run all the time in the background as a service, so that you can have this virtual drone at a very low cost all the time, running in the cloud, that you can connect to from any computer, as long as you have the IP address from anywhere in the world, and do your development without having to worry about having to turn the virtual drone on or off every time you want to do something with it. So we're going to use a service called Linode. There are a lot of cloud services, for example, Amazon Web Services, DigitalOcean. They are changing from year to year, so you do you, but Linode is the one we're going to use. So first thing we need to do is, before I do that, let me show you the GitHub repo of this set of scripts that I have created. So there's two install scripts and the README, which explains how it works. So if you run these install scripts on a Linux machine, it could also be a local desktop, but I'm designing this to have a Linux machine in the cloud. It installs all this software for you automatically. You don't have to read the ArduPilot documentation or do any work. And then it automatically creates a virtual drone in the cloud that you can fly by connecting to it. And to connect to it, you just need the IP address of the server, port 5678. You can also log into your remote server over SSH and run these commands manually if you want to manually turn the drone on and off and so on, but I'm more interested in having it just always on in the background as a service. So all you really need is Linux and to run this script and you're good to go. So let's create a Linux instance. So Linode is one company that's traditionally very inexpensive. So I already have an account there, and we're just going to spin up a Linux instance. And we're going to use Ubuntu 2404, and there's many different price plans. We're going to go with the very, very cheapest one because we don't need very much power. Once the software is installed, it's a very small amount of computational power that we're going to need. So the shared CPU Nanode 1 GB is $5 a month, and that's what we're going to use. We have to have a password and create it. So let's go ahead and get it started. And that will take a moment. So we just have to wait for that Linode instance to spin up. Now, installing the software requires some compilation, so it's actually going to be quite slow to install it. Even with 4 quad-core CPU and a high-end CPU, it's going to be, it took me about an hour to do all the compilation. So I'll speed it up for this one, which is slower, but this is very reasonable price. And also, right now, Linode is having a special that if you sign up, you get $100 of free credit. So if it's $5 a month, you can do the math. You can have a very inexpensive virtual drone in the cloud that you can always refer to. Okay, while it's getting started, there's one issue I have to explain, which is you cannot, ArduPilot scripts that we're going to be using do not like to run as root. So we can't log in as root to Linode. So when we get the Linode instance spun up, we're going to have to create a separate user account that we can use to install all the scripts. Otherwise, ArduPilot just won't like it. Okay, so it's booting, and we'll just wait. Now it's running. So we'll go over firewalls now, but right now this is wide open. So we have our IP address. So I'm just going to SSH into that machine and type in the password. And there we go. We're in our Linode instance. Let's clear that. And to install this, so first we're root. We need to be a different user. So I'm going to create an account called DronePilot. You click on these squares, that'll copy this text. Come over here and click paste, click enter, and we just created a new user called DronePilot. Oh shoot, let's do that again. And we have the password updated, so I need to log out, and now I need to log in as the new user, DronePilot. There we are. So now we're logged into this Linode instance. Let me zoom in just for clarity. Okay, so, and let's zoom into this GitHub repo here. So all we need to do to install it is to clone the GitHub repository, which only has these 2 scripts. Install.sh has about 100 lines of code. It just installs ArduPilot. And then install drone service.h has about 100 lines of code. It installs the service that's going to run in the background. The service that runs in the background just runs on boot. Oops. And all it does is run this simple command: simvehicle.py arducopter mav proxy runs as a daemon because we don't have a GUI. It connects on 2 different ports, TCP and UDP, and I have the drone at a custom location, which you'll see when we do the demo. So that's all this repo is. It's very, very small repo, very lightweight. So we clone it to our Linode instance, move it to the directory, and we're running it. Okay, so let's copy that command, paste it here, and run it. Now we can install just the manual part if you want, but we want to the full install. I may have not typed that right. Okay, so it's 6:20 now, and it's probably going to be at least an hour to install this. I'll speed it up in the video, and you'll see it when it's complete. Okay, and we're done. Let's see what the status is of our virtual drone. This looks like it's getting started. Oh, that's going to take a few minutes, so let's wait for that. Okay, so there's the status. Seems like everything's working. And let's try to log into the drone from Mission Planner. Okay, so we moved over to Windows where I have Mission Planner. And let's try to connect to our virtual drone with Mission Planner. We need the drone, we need the IP address of the Linode instance. So I can log into my Linode account, and there it is. 172 blah blah blah. So let's boot Mission Planner. Now to connect, we're going to use TCP IP. We're going to click connect. Use that IP address. Enter remote port 5678. Okay.
Mode change to stabilize.
Here we go. We're connected to the virtual drone. And I have it set up to spawn right in the center of Aldrich Park at UC Irvine. So let's check that we can make it work. We can arm it.
Armed.
Disarm it.
Disarmed.
We can set the mode. Well, we can
armed.
Arm it, and then somehow right click on here. Click take off. Take off to 5 meters.
Mode change to guided.
Changes to guided. Drone takes off. Then I can right click, fly altitude 100. Well, that's pretty high. Right click, fly to here. And the drone, you can see the virtual drone now starts to fly over to that point we put on the map. You can see its altitude here is climbing 25 meters. It's moved a little. Its speed is 4 meters per second. So we can let it get to that point, or we can just hit return to launch.
Mode change to RTL.
It changes to RTL. Turns around. Starts heading back toward home. Once it gets to home, it'll descend and land. So you can see the virtual altitude is 55 meters. That's above the ground. Don't worry about the trees. I don't think they're modeled in the software. So now it's going to descend 48 meters, 45, 44, etc. Nice slow landing so we don't crash our virtual drone. All these other parameters are simulated here: satellite count, battery voltage, battery current. All these are simulated in the virtual drone model. So 8 meters, 7 meters. GPS is fixed. Vibration is good. You can do everything on a virtual drone that you can do on a real drone. So it's a good way to test ground control station software without any risk.
Disarmed.
And it landed at 0 meters. And that's how you create a virtual drone.